This is section 3.2, part B, logarithmic functions. The I can statement for this half of the section: I can sketch and analyze graphs of logarithmic functions. So you can use the inverse relationship between an exponential and a logarithmic function to graph the function of the form y is equal to the log base b of x. To do this, we're first going to write it in exponential form, and we know it's the inverse of it. So then when we're done, we can just switch the x and the y and then graph our function. So we need to find f of x is equal to log base 3 of x, and we need to be able to graph it. Now, instead of f of x, we do have y. Remember, this is your b value. We have our y and we have our x. So if we write this, the inverse function will be 3 to the y is equal to x. So if our original function can be written in the form of 3y is equal to x, to be able to find the inverse of this, remember you switch your x and your y. And if we switch our x and our y, we're going to have 3 to the x is equal to the inverse of y, or we can write that as 3 to the x is equal to the inverse function of x. So if we use our inverse function, the inverse function of x is equal to 3 to the x. If we plug in values of x to solve for values of y, we can then switch the x and the y values to get our original function values to be able to graph them. So let's plug in x values for -3, -2, -1, 0, 1, 2, and 3. So if we plug in -3 for our x, 3 to the -3rd is going to give us 0.04 approximately. -2 is going to give me 0.11. -1 is 0.33. 3 to the 0 power is just going to give us 1. 3 to the first is 3. 3 to the second is 9. And 3 to the third is 27. But that's the inverse of our log function. So to find the actual function, all we're going to do is we're going to take our x and y values and we are going to switch them. So everything that's an x on the inverse will become a y on our function, and everything that's a y on the inverse will be an x on our actual function. Now if we go to graph this, at an x value of 0.04, we are at -3. At 0.11, we are at -2. At 0.33, we are at -1. And when we have a value, an x value of 1, we are at 0. At x is 3, we are at 1. X is 9, we are at 3. So our graph is going to look something like this. Now it says once we have it sketched, we are going to describe the domain, range, intercepts, asymptotes, and behaviors, and where the function is increasing and decreasing. As you can see, it is all going to be greater than x is equal to 0. So for our domain, we are going to go from 0 to infinity. Our range, it goes all the way down and it goes all the way up. The arrows are pointing both directions. So our range is -infinity to +infinity. We do know we are crossing the x-axis at x is equal to 1, but we are not crossing the y-axis. So we do have an x-intercept, x equals 1. Our y-intercept There is not one, so there is none. We do have an asymptote. As you can see, our graph is approaching the y-axis, but it's never actually touching it. So we do have an asymptote at x is equal to 0. Our end behaviors. Our graph is going to begin at x is equal to 0. It's actually to the right of it a little bit. But we do have a end behavior on the right side. So it's not going to be all the way to the left. It's going to be 0, but a positive 0 because it's not going to actually reach 0. So on the left side, as it gets closer and closer to 0 on the positive side, it is going down forever. So we are negative infinity. The limit on the right side of our function is going up forever. So that will be a positive infinity. And our graph is increasing from 0 to the x value of infinity. Again, for this function, we're going to write it as an exponential first. Then we're going to find the inverse to find the values, and then graph those values. So if we have y is equal to, we can change this f of x to y. So y is equal to log base 1/2 to the x power. We can rewrite that as 1/2 raised to the y is equal to x. So if our f of x function is 1/2 of y is equal to x, the inverse of that, we're going to switch the x and the y. Our inverse of y is equal to 1/2 x because we switch the x and the y, so it makes it the inverse. Or the inverse function of x is equal to 1/2 x. If we make a table of x and y values, we're going to pick our x values. We're going to plug them into that inverse function, and then we're going to find the y values. So if we plug in our x values, 1/2 to the negative third is 8, 1/2 to the negative second is 4, 1/2 to the negative first is 2, 1/2 to the 0 power, anything to the 0 power is 1, 1/2 to the first is 0.5, 1/2 to the second is 0.25, and 1/2 raised to the third power gives us 0.125. Now we're going to find the actual function itself. And our original function is f of x is equal to log base 1/2 of x. Remember, all of your y's on the inverse now become your x's. And all of your x's become your y's. So if we go to graph our original function, we have an x value of 8. We have a y value of negative 3. If we have an x value of 4, we have a y value of negative 2. X is 2, y is negative 1, x is 1, y is 0. Again, it's getting closer and closer to that y-axis, but it never actually touches it. Again, we need to state the domain, range, intercepts, asymptotes, and behaviors, and whether it is increasing or decreasing. So if we take a look at our domain, again, it's only going to start to the right of the y-axis. So our domain is going to go from 0 to infinity. Our range, the arrows point up and down. So our range is going to be negative infinity to infinity. Our intercepts, y-intercept, we still don't have one. our x-intercept, we are crossing that x-axis at 1. Asymptotes is approaching the y-axis but never actually touches it. So we have an asymptote at x is equal to 0. Our end behaviors, again, it is not going to the left of the y-axis. So our left end behavior is going to be the limit as x approaches 0 on the right side of it, so on the positive side of 0 of f of x, and that's going up forever. The limit on the right side of the function is going down forever, so that'll be negative infinity. And we can see that this graph is decreasing on the entire graph. But we just say what the x values are. Since we only have x values from 0 to infinity, we know it's decreasing from 0 to infinity. Now before we start this problem, if you remember back to the first example we did, if the log base is 1 or greater, it is going to go up to the right. It's going to go down on the left side of it, go up on the right. If your base is between 0 and 1, it's going to start up and it's going to go down to the right. But both times and every time, it is going to cross at x is 1 and y is 0. This should make sense because on our exponential functions, we always crossed at 0, 1. Since the log is the inverse of it, we are going to cross at 1, 0. So on just a regular log function, if my f of x is log base 10 of x, we know we are going to cross at 1, 0. We know we're going to get close to the y-axis here, and we're going to go up to the right. Now we can use our same transformation functions that we used with our exponentials and with algebraic functions. This says I'm going to have log of x plus 4. This plus 4 is on the x, so that means it's going to shift it horizontally. Remember, when you pull it out of the parentheses, it means you are going to change the sign. So I'm going to translate this 4 units to the left. So instead of crossing at 1, 0, we're going to translate 4 units to the left. I'm going to cross here. Our asymptote is also going to move. Instead of being the y-axis, it's going to shift over 4. So our asymptote is going to be located at y is equal to negative 4. And our graph is going to get closer to the asymptote on the left and go up on the right. Now on this one, we still have a log base 10, so we still know the original function is going to go up to the right. It's going to cross at 1, 0. It's going to get closer to my asymptote here, and it's going to go up to the right. Because the negative function is in front of the log, it's on the entire function, so we are going to reflect it across the x-axis. So if we take this original function, that means now it's going to get closer up here, and then it's going to go down this direction because we flipped it across the x-axis. But we also have this minus 5. It is not on the x itself. It is outside of the function because it's not inside the parentheses. So that means it's on the whole function of the y, which means it's going to shift it vertically. Because it is negative, it's going to translate it down 5 units. So instead of crossing at 1, 0, we're going to cross at 1, negative 5. It's still going to go up and get closer to the y-axis here and go down to the right. So our g of x will be that red graph. On this last one, we still have a log base 10, so we still know it's going to go up to the right originally. Now we have a 3 out in front of it. This is a 3 times the entire function itself. The function is y, so 3 times the y means it's going to be vertically. Because this is larger than 1, we know it's going to expand it vertically by a factor of 3. Then we have x plus 2. That plus 2 is only on the x value, and x is horizontal or left or right. Remember, when you pull it out of the parentheses, you have to change the sign. So this is going to translate it 2 units to the left. So instead of starting across at 1, 0, we go 2 units to the left. It is going to start at negative 1, 0. It also shifts our asymptote over to negative 2. Our graph is still going down, but it's expanding it vertically. So it's going to stretch it up more on our curve because it's going to be 3 times up.